So let's talk about something at the very heart of artificial intelligence, trust. I mean, how can you really prove an AI is telling you the truth, especially when its story can change in, the blink of an eye? Well, that's the whole idea behind something called the AI audit trail.
Just picture this for a second. You're a serious researcher, right? Your whole career depends on accuracy. And the AI system you rely on, it just changes a critical date in your research. Poof, gone. No explanation, no record of what it was before, just a flicker on the screen. This one line from a super frustrated researcher is really where a whole story kicks off. It's not just an annoyance, it's a demand for proof.
And look, this isn't just some made-up scenario. This is the very core of what you could call a crisis of trust. In the source material we're looking at, a junior engineer, his name's Timothy, is dealing with this exact thing. An AI corrected a citation, which sounds good, right? But with zero trail to follow, the correction just looks like a mistake. The user is mad, and the AI's credibility, it's totally on the line.
And this is where Margaret, the senior engineer in our story, steps in with a really crucial point. She says, for an AI to be truly trustworthy, being correct isn't enough. It has to be auditable. What does that mean? It means we need a way to go back and check the tape, to examine and verify every single decision the system makes, every tiny piece of information it changes.
Okay, so what does that actually look like in practice? Well, it's a massive shift in how we think about these AI systems. We've got to move away from this black box approach, the whole just trust us model, where everything happens behind a curtain. The new way? It demands what's called immutable traceability. It's a system that doesn't ask for your trust. It earns it by saying, here's the proof, see for yourself.
Margaret's big solution is something she calls the Scarlet Ledger. And honestly, the best way to think about it is like a flight recorder, the black box, but for an AI. It's this permanent, totally unchangeable record of every single action, every decision, every correction. It's built to capture the truth and lock it down, no matter what happens later on. All right, so build a flight recorder for AI sounds cool, but how do you actually do it? Margaret breaks the whole thing down into 5 core engineering principles. Think of them as the 5 pillars holding up this entire structure of trust. And now we're going to walk through every single one.
Right away, Timothy, the junior engineer, asks the most obvious and most important question. Okay, but how do we prove the log itself hasn't been changed? I mean, he's right. A log is completely useless if someone can just go in and edit it after the fact. So how do you trust the proof itself? It's such a brilliant and totally essential question to ask.
And the answer is pillar number 1, immutable audit logs. The magic here is something called cryptographic hashing. Basically, it mathematically chains every new entry to the one before it, creating this unbreakable digital chain. And it's all written to what's called an append-only store. It's a fancy term, but it just means you can add new stuff, but you can never, ever go back and change or delete the old stuff. It's locked in. So the process itself is pretty straightforward. Step 1, the AI gives its answer. Step 2, a human reviewer can flag it for a second look. This is the Scarlet flag. Step 3, an expert, in this case a librarian, signs off on the change, confirming it's correct. And only then, after all that, does the whole sequence get cryptographically locked into the ledger, forever.
Okay, so that sounds great, but wait a minute. This kind of radical transparency creates a brand new problem, right? If you're logging everything, what happens to user privacy? A log that's full of people's private questions about their health or their finances, that is a compliance and ethical nightmare just waiting to happen.
And that brings us to the second pillar, PII redaction. PII is just shorthand for personally identifiable information. So before anything gets written to that permanent log, this system is smart enough to automatically find and black out, or redact, all the sensitive stuff. We're talking names, emails, anything that could possibly identify a specific person.
And this is the key takeaway, right here. The log proves what was decided and why it was decided, but it never has to reveal who asked the question in the first place. That simple but powerful distinction is how you solve that giant conflict between transparency and privacy.
And Timothy's on a roll. He raises another fantastic point. He's like, okay, the audit trail is great, but what if the AI's answer came from a source document that was just wrong to begin with? The classic garbage in, garbage out problem. How does the ledger deal with the quality of its own sources? That's pillar number 3, provenance tracking. It's a great term. The system doesn't just give you the answer. It gives you a map that traces the information all the way back to its original source. And it's not just the source. It includes extra data, metadata, like how authoritative is this document? When was the last time a human verified it? It puts the power back in the user's hands to judge the source for themselves. So at this point, we have this incredibly powerful, super secure, and really detailed log. But let's be real, all that raw data can be completely overwhelming. So how do you show this complex chain of evidence to a regular person, like our researcher, without their eyes just glazing over? How do you make it helpful, not just confusing?
And that is pillar number 4, explainability. Margaret's idea here is brilliant in its simplicity. Just a show your work button. You click it, and it translates that complicated log into a simple, human-readable story. The AI first said this, then a human flagged it, and finally, an expert checked it against this specific document. All of a sudden, transparency isn't some abstract concept, it's a feature you can actually click.
And finally, we get to the brass tacks. The practical question, money. Storing all this data forever? That gets expensive fast. Do we really need to keep every single little log entry for all of time? The costs could literally become astronomical. The fifth and final pillar is just a smart retention policy. You have to realize that not all data is created equal. So routine stuff, logs just for debugging, get rid of those after 90 days. But the really important stuff, the compliance-critical logs for, say, legal or medical info, you keep those for a standard period, maybe 7 years, and after that, they're automatically deleted. The system has a memory, but it's not a data hoarder. Okay, so now let's circle all the way back to where we started. Remember that annoyed researcher in Timothy's office? Well, now, with these 5 pillars built into the system, Timothy has the Scarlet Ledger. He can finally give that researcher the proof they demanded. So Timothy pulls up the ledger entry, and it's all right there. The whole system's power, in action. He can show the researcher step by step. Here's the first incorrect answer from the AI. Here's the scarlet flag from a human evaluator. Here's my own sign-off as the librarian. And, this is the clincher, here's a link to the exact 17th century manuscript we used to confirm the correct date.
And the result? It's like a switch flips. The researcher's annoyance just melts away. It's completely replaced by this look of scholarly respect. See, the correction is no longer some random insulting error. It's a verifiable, transparent, and trustworthy piece of data. The proof, it just changes everything.
So as we start to wrap this up, it becomes really clear that an audit trail is so much more than just a technical feature. It's not just some log file sitting on a server. It's the entire framework for a system's integrity. You could even say it's how a system proves it actually has a conscience.
Margaret's final line in the story just perfectly captures this whole philosophy. She says that all the hard work, building a trustworthy AI, that happens behind the scenes. It happens in the code, in the dark, as she puts it. But the trust itself, that relationship with the user, that can only ever be proven when you bring all the facts out into the light of the log.
And that really leaves us with one final question to chew on. Whether you're someone who builds these AI systems, or, like most of us, you just use them every single day, it's worth asking yourself, does the AI in your life have a conscience? Can it show you its work? Can it prove the truth? Because at the end of the day, that might be the only thing that truly matters.